Hello everyone, in this video we're going to review apcalculus, BC, intros and their applications. Alright, before we're going to dive into questions, let's review some concepts behind this topic. First, we have the formula antiderivative of k f of s ds is going to be k times antiderivative of f of s ds. Number 2. Antiderivative of f of s plus and minus g of s ds equals antiderivative of f of s ds plus and minus antiderivative of g of s ds. Number 3. Antiderivative of ds equals s plus c. Number 4. Antiderivative of s to the n ds equals s to the n plus 1 over n plus 1 plus c. Number 5. Antiderivative of ds over s is going to be ln absolute value of s plus c. Number 6. Antiderivative of a to the s ds equals a to the s over ln a plus c. Number 7. Antiderivative of e to the s ds is going to be e to the s plus c. Number 8. Antiderivative of e to the as plus b ds is going to be 1 over a e to the as plus b plus c. Number 9. Antiderivative of ds over square root of a square minus s square equals sine of s over a plus c. Number 10. Antiderivative of ds over a square plus s square is going to be 1 over a tangent of s over a plus c. Number 11. Antiderivative of sine s ds equals negative cosine s plus c. Number 12. Antiderivative of sine of a s plus b ds is going to be negative 1 over a cosine of a s plus b plus c. Number 13. Antiderivative of cosine s ds equals sine s plus c. Number 14. Antiderivative of cosine of a s plus b ds equals 1 over a sine of a s plus b plus c. Number 15. Antiderivative of secant square s ds is going to be tangent s plus c. Number 16. Antiderivative of cosecant square s ds is going to be negative cotangent s plus c. Number 17. Antiderivative of secant s tangent s ds is going to be secant s plus c. Number 18. Antiderivative of cosecant s cotangent s ds is going to be negative cosecant s plus c. Number 19. Antiderivative of tangent s ds. This guy actually antiderivative of sine s over cosine s ds, right? And it's going to be negative ln absolute value of cosine s plus c. Number 20. Antiderivative of cotangent s ds is going to be antiderivative of cosine s over sine s ds, and it's going to be ln absolute value of sine s plus c. Number 21. We're going to talk about the average value of the function. It's going to be 1 over b minus a, the integral from a to b of f of s ds, right? Number 22, integration by part. The antiderivative of u dv is going to be u times v minus antiderivative of v du, right? And remember, in order to do integration by part, you need to know the acronyms L, I, A, T, E. Alright, to memorize this one, just know this. Lion 8. L stands for logarithmic. Number 23. We're going to talk about the fundamental theorem of calculus. We have the integral from a to b of f prime of s ds is going to be f of b minus f of a, right? Where f is the antiderivative of f prime, right? So then you have f of b equals f of a plus the integral from a to b of f prime of s ds. This formula is used a lot in the contest. Now we have the fundamental theorem of calculus in contest. We have the current amount equals initial amount plus the integral from t1 to t2 of rate in subtract rate out. dt. Now number 24, we have the improper integrals. The integral from a to infinity of f of s ds equals limit of the integral from a to b of f of s ds when b approaches infinity. Number 25, the integral from negative infinity to b of f of s ds equals limit of the integral from a to b of f of s ds when a approaches negative infinity. Now number 26, if the function ls has a vertical asymptote at s equals a, then the integral from a to b of f of s ds equals limit of the integral from s to b of f of s ds when s approaches a plus. Number 27, if the function ls has the vertical asymptote at s equals b, then the integral from a to b of f of s ds equals limit of the integral from a to s of f of s ds when s approaches b minus. Now number 28 is the combination of this guy and this guy. If you have the integral from negative infinity to positive infinity of f of s ds, it's going to be limit of the integral from t to a of f of s ds when t approaches negative infinity. Limit of the integral from a to t of f of s ds when t approaches positive infinity. Now let's move on to question 1. We need to calculate the integral from 1 to e of s squared plus 1 over s, right? So because degree on the numerator is greater than degree on the denominator, we just do long division, or we just separate this one, right? So it's going to be the integral from 1 to e of s plus 1 over s ds, right? So it could be s squared over 2 plus ln absolute value of s evaluated from 1 to e, right? So it could be e squared over 2 plus ln absolute value of e, subtract 1 over 2 plus ln of absolute value of 1, right? So it's going to be e squared over 2 plus 1, right? Minus 1 half. This guy equals 0, right? So it's going to be e squared plus 1 over 2, right? So the answer must be B. Now question 2. We need to calculate the integral from 1 to infinity of s times e to the negative s squared ds. So this guy, we can use the u-substitution, right? So we have u equals negative s squared. Then du equals negative 2s ds. Then s ds equals negative 1 half du. So then the antiderivative of s e to the negative s squared ds becomes negative 1 half antiderivative of e to the u du, right? So this guy becomes negative 1 over 2 e to the u, right? So substitute this guy back for u, right? So it could be negative 1 half e to the negative s squared, right? This guy right here becomes limit of the integral from 1 to a of s e to the negative s squared ds when a approaches positive infinity equals limit of negative 1 over 2 e to the negative s squared evaluated from 1 to a. So it's going to be limit of negative 1 over 2 e to the a squared plus 1 over 2 times e when a approaches infinity. Now when a approaches infinity, this guy approaches 0, right? So we only have 1 over 2e left, right? The answer must be B. Now question 3. We need to use u-substitution, right? So we're gonna let u be s cubed. Then du equals 3s squared ds, right? And then s squared ds equals 1 over 3 du, right? So this guy becomes the antiderivative of cosine u du, and don't forget to put 1/3 right here, right? So it's gonna be 1/3 sine u plus c, right? But u equal this guy, right? So it could be 1/3 sine of s cubed plus c, right? The answer must be B. Question 4. The graph of a piecewise linear function f is given. What is the value of this guy, right? So we just separate this guy. It's going to be the integral from negative 1 to 9 of f of s ds. Don't forget to put 3 in the front. Plus 2 times the integral from negative 1 to 9 ds, right? Now, the integral from negative 1 to 9 is going to be the error under the curve, right? So we need to calculate the error of this trapezoid. The error of the right triangle right here, right? So it's going to be 3 times base 1 is 1, 2, 3. Base 2 is 1, 2, 3, 4, right? So 3 plus 4 times the height is going to be 1 right here, divided by 2. Plus this one, the height is 2. The base is 1, 2, 3, 4, 5, 6, right? So it could be 6 times 2 divided by 2. Plus 2s evaluated from negative 1 to 9. So it's going to be 27.5. Now question 5. if dy over dt equals this guy, if y equals 12, t equals 0, what is the value of y when t equals 10? Alright, so this guy actually y prime of t equals e to the 0.2 t, right? So we need to use the fundamental theorem of calculus, right? The final amount equals initial amount plus the integral from t1 to t2 of f prime of t dt, right? So the final amount, which means y of 10, right, equals y of 0 plus the integral from 0 to 10 of y prime of t dt, right? So we substitute value y of 0 equals 12 right here, plus integral from 0 to 10 of e to the 0.2 t dt, right? So previously we have the antiderivative of e to the a s plus b ds is going to be 1 over a e to the a s plus b plus c, right? So it's going to be 12 plus 1 over 0.2 e to the 0.2 t evaluated from 0 to 10, right? So it's going to be 12 plus 1 over 0.2 times e to the 0.2 times 10, subtract e to the 0.2 times 0, right? So we're going to simplify this one. It's going to be 12 plus 1 divided by 0.2 is going to be 5, right? Times e squared minus 1, right? So it's going to be 5e squared plus 7. This one is the final answer. The answer must be C. Now question 6. Which of the following limits is equal to this guy? Alright, so we know that the function f of s is e to the s, right? The interval a, b equals negative 3, 1, right? So we have delta s equals b minus a over n. It's going to be 1 minus negative 3 over n, right? So it's going to be 4 over n, right? So we need to eliminate b and c, right? Delta s is right here. Now we need to calculate the length of the rectangle. It's going to be f of ci, right? And this guy actually f of a plus k delta s, right? Now it's going to be f of a equals negative 3 plus k times 4 over n, right? So we're going to simplify. It's going to be f of negative 3 plus 4k over n, right? So the function f of s is right here. It's going to be e to the negative 3 plus 4k over n. We need to rewrite this guy as the limit notation, right? So it will be limit when n approaches infinity, put the summation notation right here. K goes from 1 to n of the length times the width, right? The length is right here. E to the negative 3 plus 4k over n, right? Times the width is going to be right here. 4 divided by n, right? So the answer must be D. Now let's move on to question 7. If the integral from 1 to 3 of f of s plus 5 dx equals 7, then what is the value of this guy, right? So first we need to find the integral from a to b of f of s first, right? So we look at this one right here. We have two different ways to do it. The first way, we can use u-substitution, u equals s plus 5, right? The second one, we can do this one faster by adding 5 into this guy right here. And this guy go back to f of s, right? So it's going to be the integral from 5 plus 3 is going to be 8. 5 plus 1 is going to be 6. And this guy becomes f of s, right? and it's still 7, right? Now this guy right here can be written as the integral form 6 to 8 of f of s ds plus 2 integral form 6 to 8 ds, right? But this guy right here equals 7 right here, right? So 7 plus 2s evaluated form 6 to 8, right? So it could be 7 plus 2 times 8 minus 6 is going to be 11. The answer must be D. Now let's move on to question 8. A rain barrel collects water off the roof of a house during 3 hours of heavy rainfall. The height of the water in the barrel increases at a rate of T equals this guy feet per hour, where T is the time in hours since the rain began. At time T equals 1 hour, the height of the water is 0.75 foot. Which of the following is the best interpretation of the integral from 1 to 2 of this guy? So this guy actually the fundamental theorem of calculus, right? Remember we have the integral from a to b of f prime of s ds is going to be f of b minus f of a, right? The left hand side the integral from a to b of the rate. The right hand side should be the change, right? So the change in height, right? So we look at the answer choice right here, only B correct, the change in height of the water in barrel, right? Now let's move on to question 9. We need to use u-substitution, right? So u equals s squared minus 3, then du equals 2s ds, right? Then we have s ds equals 1/2 du, right? We need to create the new upper bound and lower bound, right? So the old one s equals -1, s equals 4. The new one u equals substitute -1 for s over here, it's going to be -2. Substitute 4 for s over here, it's going to be 13, right? So this guy becomes the integral from -2 to 13, right? S ds equals 1/2 du. I put 1/2 in the front, right? And this guy is going to be u to the fifth du, right? So the answer must be C. Question 10. For what value of k, if any, is this guy equals 1, right? So we look at this one, we need to use the integration by part. So remember we have L, I, A, T, E, right? Now we look at this expression over here, we don't see log, right? So we eliminate this one. We don't see the inverse strict, right? Eliminate this one. But we have the algebraic right here, s, right? So we have let u equals s, then du equals ds, right? dv equals e to the negative 2s ds, right? And then v equals -1/2 e to the negative 2s. So then this guy right here becomes limit of the integral from 0 to b of k s e to the negative 2s ds when b approaches infinity equals limit when b approaches infinity of, we have the formula antiderivative of u dv equals u times v minus antiderivative of v du, right? So we have u times v, this guy times this guy, right? So it could be -1/2 s e to the negative 2s evaluated from 0 to b, right? Minus the integral from 0 to b of v du, right? So it could be this guy times this guy. So we have -1/2 right here, it becomes +1/2, right? E to the negative 2s ds, right? So it's going to be limit when b approaches infinity of k times substitute b for s, right? It's going to be -1/2 b times e to the negative 2b, right? Now for this guy, take antiderivative of this one, it's going to be -1/2 and 1 half right here is going to be negative 1 over 4, right? E to the negative 2s evaluated from 0 to b, right? And it's going to be limit when b approaches infinity of k times negative 1 over 2b e to the negative 2b minus substitute b for s is going to be 1 over 4, right? Times e to the negative 2b minus e to the 0, right? So it's going to be limit when b approaches infinity of k times negative b over 2 times e to the 2b, right? Minus 1 over 4 e to the 2b plus 1 over 4. So we have limit when b approaches infinity of negative b over 2 e to the 2b equals limit when b approaches infinity of negative 1 over 4 e to the b, right? So when b approaches infinity, this guy approaches 0, right? Similarly, this guy approaches 0, right? So we only have 1 4 left, right? So this guy becomes k times 1 4, which means k over 4, right? But this guy equals 1, right? So we have k over 4 equals 1. Then k equals 4, right? So the answer must be C. Question 11. We need to find the integral from 1 to e of ln(s) over s cubed ds, right? So this guy is the same thing as integral from 1 to e of s to the negative 3 ln s ds, right? So we need to use the integration by part. ln s, right? Then du equals 1 over s ds, right? dv equals s to the negative 3 ds, right? Then v equals negative 1 over 2s squared, right? So this guy right here becomes u times v is going to be this guy times this guy, right? Evaluated from 1 to e minus v du, right? So you have negative side here becomes positive, right? du right here. So it's going to be integral from 1 to e of 1 over 2s cubed ds, right? So it's going to be negative ln e over 2e squared. Subtract right here becomes positive, right? ln 1 over 2 times 1 squared, right? Plus the integral from 1 to e. Now I'm going to bring 1 half to the front. And this one right here I bring to the top. I'm going to use the power rule, right? ln 1 equals 0, right? ln e equals 1, right? So the first one becomes negative 1 over 2e squared, right? Now this one becomes 1 half times negative 1 over 2s squared evaluated from 1 to e, right? So it's going to be negative 1 over 2e squared minus 1 over 4 times 1 over e squared minus 1 over 1, right? Now I'm going to simplify this guy. So it could be negative 1 over 2e squared minus 1 over 4e squared plus 1 over 4. Now the LCD is 4e squared, right? So I have 4e squared. The top should be negative 2 minus 1 plus e squared. So it could be e squared minus 3 over 4e squared. This one is the final answer. The answer must be B. Question 12. let f be a differentiable function such that which of the following could be fs. Alright, so we're going to use the integration by part, right? Again, right over here, L I A T E, right? Let u equals f of s, then du equals f prime of s ds, right? dv equals sine s ds, then v equals negative cosine s, right? So it's gonna be this guy times this guy, right? So it's gonna be negative cosine s f of s minus v du, right? This guy times this guy. So you have plus cosine s f prime of s ds. The first guy right here and this guy right here the same, right? Now this guy right here we have cosine s ds, it could be right here. So f prime of s equals 4s cubed, right? Take anti-derivative both sides with respect to s, right? So we have f of s equals 4s to the 4 over 4, right? So then it's gonna be s to the 4, right? The answer must be E. Question 13. Which of the following statement about the integral from -1 to 1 of 1 over s squared ds? Alright, so observe that within the interval -1 to 1, the function f of s is 1 over s squared is undefined at s equals 0, right? So then the function f of s right here has the vertical asymptote at s equals 0, right? This guy can be written as the integral from -1 to 0 of 1 over s squared ds plus the integral from 0 to 1 of 1 over s squared ds, right? So we're going to use the limits, right? So limit of the integral from -1 to a when a approaches 0 minus, right, of 1 over s squared ds plus limit of the integral from b to 1 of 1 over s squared ds when b approaches 0 plus, right? So it's going to be limit when a approaches 0 minus of -1 over s evaluated from -1 to a plus limit when b approaches 0 plus of -1 over s evaluated from b to 1, right? Limit when a approaches 0 minus of -1 over a subtract 1, right? Plus limit when b approaches 0 plus of -1 plus 1 over b. So when a approaches 0 minus, this guy right here does not exist, right? This guy right here does not exist, right? So the answer must be D. Now let's move on to question 14. The table above gives value of f prime, g prime for selected value of s. If we have this guy, then this guy equals how much, right? So basically, we need to use the integration by part. Let u be f of s, then du equals f prime of s ds, right? dv equals g prime of s ds, then v equals g of s, right? This guy right here becomes u times v is going to be this guy and this guy, right? f of s, g of s evaluated from 0 to 1 minus v du, this guy times this guy, right? So it could be integral from 0 to 1 of f prime of s times g of s ds, right? Now we need to substitute 1 for s, right? So we have f of 1 times g of 1 subtract f of 0 g of 0, right? This guy right here actually 5 right here, right? subtract 5. So it could be f of 1 is going to be 4. G of 1 is going to be 3. 4 times 3 equals 12. Subtract f of 0, 2. G of 0, negative 4. So it could be plus 8 minus 5. So it could be 15. Right? The answer must be E. Now let's move on to question 15. We need to calculate the integral from 1 to 3 of this one, right? Observe that the degree on the numerator is bigger than the degree on the denominator. We need to do long division, right? So we're going to put this one on the side. So 3s cubed divided by s is going to be 3s squared. Multiply that. So it will be 3s cubed, right? 3s squared times 5 is going to be 15s squared, right? You subtract, it's going to be 0, right? Bring s plus 9 down. S divided by s could be 1, right? So it could be s plus 5. Subtract, it could be 4, right? So this one can be written as the integral from 1 to 3 the quotient right here. 3s squared plus 1 plus the remainder is 4 divided by the divisor right here. S plus 5 altogether ds. Right? So, antiderivative of this one is going to be s cubed plus s, right? This guy right here is going to be 4 times ln of absolute value of s plus 5, right? Altogether, evaluated from 1 to 3. So it could be 3 cubed, it could be 27, plus 3 it could be 30, right? So we have 30 plus 4 ln of 8, subtract 2 plus 4 ln of 6. So it could be 30 subtract 2 could be 28. Plus 4 ln 8 subtract 4 ln 6. So it could be 28 plus 4 times ln 8 subtract ln 6, right? So the answer must be 8. Now question 16, we're going to use partial fraction decomposition. So we have 7s over 2s minus 3 times s plus 2 equals, look at the bottom right here, we have two linear factors, right? So the top should be a over 2s minus 3 plus b over s plus 2, right? So the LCD is 2s minus 3 times s plus 2, right? So this guy can be written as the same LCD, right? 2s minus 3 times s plus 2, a times s plus 2 plus b times 2s minus 3, right? Now look at this guy, the bottom the same, right? We just equate the numerator, right? So we have a times s plus 2 plus b times 2s minus 3 equals 7s, right? Now to solve for a, we just let s equals 3 over 2, right? So that b is gone, right? So we substitute 3 over 2 for s into this guy, so we have a times 3 over 2 plus 2 equals 7 times 3 over 2. So it's going to be 7 over 2 times a equals 21 over 2. So a equals 3, right? Now to solve for b, we just let s equals negative 2, right? So then we have negative 7, b equals negative 14, b equals 2. Alright, so we go back over here. A equals 3, b equals 2. Now we're going to take antiderivative both sides. 3 times antiderivative of 1 over 2s minus 3. Antiderivative of du over u equals absolute value of u plus c, right? Make sure this guy must be the same. Now the bottom is 2s minus 3. This is ds, right? So I can rewrite ds as d of 2s minus 3, right? So if I take the derivative of this one, I get 2, right? So I need to divide by 2 right here, right? Plus, I do the same thing for this guy, right? So it's going to be 3 over 2 ln of absolute value of 2s minus 3 plus 2 ln absolute value of s plus 2, right? Plus c. So the answer must be A. Now let's move on to question 17. We need to use u-substitution. So we let u equals sine s, du equals cosine s ds, right? Look at the top right here, right? Now we need to change the upper bound and lower bound, right? So s equals 0, s equals pi over 2. Then u equals sine of 0 equals 0, sine of pi over 2 equals 1. So this guy right here becomes the general form 0 to 1 of du over 1 plus u squared, right? So it's going to be arctangent u evaluated from 0 to 1. It's going to be arctangent of 1 subtract arctangent of 0. Arctangent of 1 equals pi over 4. Arctangent of 0 equals 0. So it will be pi over 4. The answer must be B. Question 18. We need to find the integral from 0 to 4 of f(s) ds, where f(s) is the b-square function from 0 to 4, right? So this guy actually the error under the curve, right? So it will be, look at the s value right here, 0, right? And the discontinuous point is 2 right here. And the final one is 4 right here, right? So it will be integral from 0 to 2 of f of s ds plus the integral from 2 to 4 of f of s ds, right? The integral from 0 to 2, actually the trapezoid right here, right? Base 1 is 1, base 2 is 5, the height right here is 2, right? And since this one is above the axis, so it's going to be positive, right? So it will be 1 plus 5 times 2 divided by 2. The second one is going to be the rectangle right here, right? The length is 3, the width is 2, and since this one is below the axis, so it will be negative, right? So subtract 3 times 2 is going to be 0. The answer must be B. Question 19. We need to calculate the integral of this one, right? So basically this one can be written as, look at the bottom right here, I have e to the 2s, right? So I can rewrite the top as 1 plus e to the 2s subtract e to the 2s, right? Over 1 plus e to the 2s ds. So it's going to be the antiderivative of 1 plus e to the 2s over 1 plus e to the 2s subtract the antiderivative of e to the 2s over 1 plus e to the 2s ds, right? Now the first one is going to be antiderivative of ds, right? Minus antiderivative of e to the 2s over 1 plus e to the 2s ds, right? So for this one, it's going to be s, right? Now e to the 2s ds, I can rewrite this one as d of 1 plus e to the 2s, right? Over 1 plus e to the 2s, right? Now if I take the derivative of this one, actually I get 2 e to the 2s ds, right? But I only have e to the 2s ds right here, so I need to divide by 1/2 right here, right? So I put 1/2 in the front, so things doesn't change, right? So then I can apply the formula du over u is going to be ln absolute value of u plus c, so keep that in mind. So it will be s minus 1 over 2 ln absolute value of 1 plus e to the 2s, right? plus C. So the answer must be D. Or you can use u-substitution for this guy right here, right? You just let u equals 1 plus e to the 2s, and then you still get the same answer, right? Question 20. The antiderivative of 1 over s squared minus 10s plus 34, right? So if you see the quadratic on the bottom, the first thing you need to do is to factor this one, right? So we need to find two numbers multiply equals 34, add up to negative 10. It is impossible, right? The second one you need to think is to do complete square, right? So this guy can be written as antiderivative of ds over s squared minus 10s, right? Plus, put a blank right here, plus 34, right? Now remember, you have a squared minus 2ab plus b squared is to be a minus b altogether square, right? So in order to find the third term right here, you're gonna take 10 right here, the middle term, divide by 2 and square is to be 5 square, right? So you just literally add 5 square, you need to subtract 5 square right here, right? So it's gonna be antiderivative of ds over the first three terms right here becomes a complete square, s minus 5 altogether square, right? Plus 34 subtract 25 is going to be 9, right? But 9 is 3 squared, right? So antiderivative of du over u squared plus a squared is going to be 1 over a, right? Arctangent of u over a plus c, right? So look at the bottom right here and look at the top right here. This guy right here and this guy right here must be the same, right? So I can rewrite ds as the antiderivative of d of s minus 5 over s minus 5 square plus 3, right? Make sure this guy and this guy must be the same, so be careful. Alright, so it's gonna be 1 over 3, right? Arctangent of s minus 5 over 3 and then as c, right? So the answer must be C. Question 21. Alright, degree on the numerator is less than degree on the denominator. Think about fraction decomposition, right? Now we need to find two numbers multiply equal to add up to 3, so it will be 5s plus 8. It turns out to be 1 and 2, right? And then it's going to be a times s plus 2 plus b times s plus 1, right? Now you just equate the numerator because denominator both the same, right? So I'm going to let s equals negative 2 to eliminate a, right? So then I substitute negative 2 for s over here, I solve for b, right? So I have negative b equals negative 2, and then b equals 2. Now I'm going to let s equals negative 1 to eliminate b, right? And to solve for a, right? So we have a equals 3, right? So I'm going to go back over here. Now I'm going to take the integral from 0 to 1 of this one, ds. It's going to be the same thing for this guy, right? Now d of s plus 1 actually ds, right? So this guy becomes 3 ln of absolute value of s plus 1 evaluated from 0 to 1 plus 2 ln of absolute value of s plus 2 evaluated from 0 to 1, right? Substitute 1 for s is going to be 3 ln 2. Substitute 0 for s is going to be ln 1 is going to be 0. Substitute 1 for s is going to be plus 2 ln 3. Substitute 0 for s is going to be minus 2 ln 2, right? So it's going to be ln 2 plus 2 ln 3. Now we look at the answer choice right here, we don't see it. So we need to manipulate the log a little bit, right? So we have ln 2 plus ln of 3 square. You can bring 2 back over here, right? Remember we have a log base b of c. You can bring a back over here, so it could be log base b of c power of a, right? So it could be ln 2 plus ln 9, right? Now you have log base a of b plus log base a of c. It could be log base a of b times c. So it's going to be ln of 2 times 9. It's going to be ln of 18, right? The answer must be C. Question 22. We need to use the fundamental theorem of calculus, right? This one is the initial one. This one is the final one, right? So f of 2 equals f of -1 plus the integral from -1 to 2 of f prime of s ds, right? So it's going to be 2.4 plus the integral from -1 to 2 of square root of 9 minus s square ds, right? Now since we are allowed to use the calculator, so we're going to print up the calculator. Add calculator 2.4 plus, hit the button right here, input the integral from -1 to 2 of, hit the square root 9 minus s squared ds. Press Ctrl Enter. It could be 10.863. The answer must be D. Now let's move on to question 23. There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate multiplied by ft equals 70 e to the cosine t cubic feet per hour, where t is measured in hours since midnight. Janet starts removing snow at 6 a.m., which means t equals 6, so 9 a.m. t equals 9, right? And midnight t equals 0, right? The rate t of t in cubic feet per hour at which Janet removes snow from the driveway at the time t hours after midnight is multiplied by this piecewise function. Question C. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain from 0 to 9. From 0 less than t less than equal to 6, then we have h of t equals the initial amount h of 0 plus the integral from 0 to t of g of s ds, right? And h of 0 equals 0 plus the integral from 0 to t, right? Within this interval, the value is 0, right? So it could be 0 ds, and the answer must be 0. Now, the second interval is going to be from 6 to 7, right? So, h of t equals h of 6 plus the integral from 6 to t g of s ds, right? 0 plus the integral from 6 to t of 125 ds, right? So it's going to be 125 s evaluated from 6 to t, right? So it's going to be 125 times t minus 6. The third interval is going to be from 7 less than t less than equal to 9. Then you have h of t equals h of 7 plus the integral from 7 to t g of s ds, right? H of 7 is going to be 125 right here, right? Plus the integral from 7 to t of 108 ds, and it's going to be 125 plus 108 as evaluated from 7 to t. It's going to be 125 plus 108 times t minus 7, right? So the piecewise function is h of t equals. Now question D. How many cubic feet of snow are on the driveway at 9 a.m., which means t equals 9, right? So you need to calculate the interval from 0 to 9, right? Of rate in subtract rate out, right? So it could be f of t dt subtract h of 9, right? So it's gonna be the interval from 0 to 9 of this guy right here, 7t e to the cosine t dt subtract h of 9 is gonna be this expression right here, right? Press Control Enter. It's gonna be 26.334. Now let's move on to question 24. Let g be the function given by g of s equal 1 over square root of s. The average value of a function f on the unbounded interval a to infinity is defined by this guy. Show that the improper interval from 4 to infinity g of s ds is divergent, but the average value of g on the interval 4 to infinity is finite. We have the interval from 4 to infinity of g of s ds equals limit when b approaches infinity of the interval from 4 to b of g of s ds, but g of s equals this one. So it's going to be limit when b approaches infinity of the interval from 4 to b of s power of negative 1/2 ds, right? So it's going to be limit when b approaches infinity of 2 square root of s evaluated from 4 to b, right? And it's going to be limit when b approaches infinity of 2 square root of b subtract 2 square root of 4. It's going to be 4, right? Approaches infinity, right? Infinity subtract 4 is going to be infinity. The interval from 4 to infinity of g of s ds is divergence. Now we need to calculate this one, right? So we have limit when b approaches infinity of the interval from a to b of f of s ds over b minus a is limit when b approaches infinity of a right here equals 4, right? So it could be 1 over b minus 4 of the interval from 4 to b of 1 over square root of s ds, right? But this guy right here has been calculated right here, right? So it could be limit when b approaches infinity of 2 square root of b minus 4 over b minus 4, right? Alright, so when b approaches infinity, this guy right here grows faster than this guy. This guy right here grows faster than this guy, right? So it's gonna be limit when b approaches infinity of 2 square root of b over b, right? Now we're gonna simplify this one, so it could be limit when b approaches infinity of 2 over square root of b, right? When b approaches infinity, this guy approaches 0, right? So this one is finite. Now let's move on to question 25. The derivative of a function f is given by this guy for s greater than 0. If f of 1 equals 7, then we need to find the value of f of 3, right? So we're going to use the fundamental theorem of calculus, right? So we have f of 3 equals f of 1 plus the interval from 1 to 3 of s minus 3 e to the s, right? Now we're gonna calculate this one on the side, right? So the integral from 1 to 3 of s minus 3 e to the s ds. We need to use integration by part, right? So we let u equals s minus 3, du equals ds, dv equals e to the s ds, v equals e to the s, right? So this guy becomes u times v, which means this guy times this guy, right? S minus 3 times e to the s evaluated from 1 to 3 minus v du, which means this guy times this guy, integral from 1 to 3 of e to the s ds, right? It's gonna be s minus 3 e to the s, subtract the entire derivative of this one, it could be e to the s, right? All together evaluated from 1 to 3, right? So I substitute 3 for s, it could be, the first one is 0, right? The second one is negative e cubed, right? Substitute 1 for s, I get subtract negative 2e, subtract e. So it's going to be negative e cubed. This guy turns out to be negative 3e, and negative right here is positive 3e, right? So finally, f of 3 right here equals, f of 1 equals 7. Plus this guy right here, 3e minus e cubed, right? This one is the final answer. Now let's move on to question 26. If dy over ds equals this guy, y equals 3, s equals 5, what is the value of s equals 5.5? Again, we're going to use fundamental theorem of calculus, right? So we have y of 5.5 equals y of 5 plus the integral from 5 to 5.5 of this guy, right? Now I'm going to calculate this one on the side. Now I'm going to factor negative side out, so that I'm going to do complete square, right? So this guy turns out to be the integral from 5 to 5.5 ds over. In order to find the missing term right here, I'm going to take the middle term right here, 10 divided by 2 and square, right? So it could be 5 square, right? So I just literally subtract 25, right? I need to add 25. Subtract 24, right? So it's going to be 1 minus s minus 5 altogether square, right? Now I want to apply the formula antiderivative of du over square root of a square minus u square. It's going to be a sine of u over a plus c, right? Now u in this situation is s minus 5, right? A in this situation is 1, right? So the top, look at this one right here. This is u, this must be u, right? So this guy must be s minus 5, right? Derivative of ds minus 5 is going to be ds, right? So they're both the same. So now I can apply the formula right here. So it's going to be sine of s minus 5 over 1, right? Because a equals 1. Evaluated from 5 to 5.5, right? Substitute 5.5 for s, so it could be sine of 1/2, right? Substitute 5 for s, it could be sine of 0, right? Sine of 1/2 is going to be pi over 6. Sine of 0 is going to be 0. So we have y of 5.5 equals y of 5 is going to be 3 right here. Plus pi over 6, right? Now let's move on to question 27. The graph of a differentiable function f is shown for negative 3 less than equal to s less than equal to 3. The errors of the region A, B, C, D are 5, 4, 5, 3 respectively. Question D. Let h be the function defined by h of s equals this guy. Find the value of the integral from negative 2 to 1 of h of s ds. Alright, so basically this guy is the same thing as the integral from negative 2 to 1 of 3 f of 2x plus 1 plus 4 ds, right? So it's going to be 3 times the integral from negative 2 to 1 of f of 2x plus 1, right? ds plus 4 the integral from negative 2 to 1 of ds, right? Now I need to calculate this one first, right? So I'm going to let u equals 2x plus 1 and du equals 2 ds, right? So ds equals 1/2 du, right? Now I need to change the new upper bound and lower bound, right? So the O1s equals negative 2, s equals 1. Then the new one, u equals, substituting negative 2 for s is going to be negative 3, right? Substitute 1 for s is going to be 3, right? So this guy becomes the integral from negative 3 to 3 of f of u du. Now I have 1/2 here, I put 1/2 in the front, right? So now I can use this graph to find the error under the curve, right? Remember this guy must be the same, right? In order to use this graph, right? So it's going to be 1/2. The first one right here, a, is going to be 5, right? The second one, b right here, is below that axis, it's going to be negative 4. The third one, c right here, is going to be 5. And the last one right here, d, is going to be 3. So the answer is 9/2. I substitute 9/2 over here, so it could be 3 times 9/2, right? Plus 4s evaluated from negative 2 to 1, right? So it could be 27/2 plus 4 times 1 plus 2, right? So the final answer should be 51/2. Sarah rode a stationary bicycle. The number of rotations per minute of the wheel of the stationary bicycle at time t minutes during Sarah ride is modeled by function s, defined by s of t equals this guy for t between 0 and 9 minutes. Find the average number of rotations per minute of the wheel of the stationary bicycle for t between 0 and 9 minutes. Alright, so we're going to use the average formula, right? So we have 1/b minus a. This is a, this is b, so it could be 9, right? Integral from 0 to 9 of s of t dt, right? So it could be 1/9. Integral from 0 to 9 of 40 plus 20 pi sine of pi t over 18 dt, right? So it's going to be 1/9 times 40 t, right? Now remember, antiderivative of sine of a s plus b ds is going to be negative 1/a cosine of a s plus b plus c. So keep this one in mind, right? So a in this situation is pi over 18. Now you just flip this one, it's going to be 18 over pi, right? It turns out to be negative 360 cosine of pi t over 18, right? Evaluated from 0 to 9, right? So I'm going to substitute 9 for t, so it could be 1/9 times 360 subtract 9 for t over here, it's going to be cosine of pi over 2 is going to be 0, so we don't have to worry about this guy anymore, right? Substitute 0 for t, this guy equals 0, right? This guy becomes negative 360, and subtract negative 360 is going to be positive 360, right? So it could be 720/9, and it's going to be 80 rotation per minute. Now let's move on to question 29. Consider the function f given by this guy. Evaluate the integral from 0 to infinity of Ls ds. The integral from 0 to infinity of s times e to the negative 2s. Limit when b approaches infinity of the interval from 0 to b as e to the negative 2s, right? So we're going to use integration by part, right? Let u be as du equals ds, dv equals e to the negative 2s ds, v equals negative 1/2 e to the negative 2s. Interval from 0 to b of s e to the negative 2s ds becomes u times v. This guy times this guy, right? It's going to be negative 1 over 2 s e to the negative 2s evaluated from 0 to b minus v du is going to be right here. So plus 1/2 interval from 0 to b of e to the negative 2s ds, right? So this guy becomes negative 1/2. Substitute b for s, so it could be b times e to the negative 2b. Substitute 0 for s, could be 0, right? Plus, now antiderivative of e to the negative 2s, it could be negative 1/2, right? So it could be negative 1 over 4 e to the negative 2s evaluated from 0 to b, right? So it's going to be negative 1 over 2b e to the negative 2b minus 1 over 4 times e to the negative 2b. E to the 0 is going to be 1, right? Now I'm going to simplify this one. So it's going to be negative b over 2 times e to the 2b, right? Distribute this one, so it's going to be minus 1 over 4 e to the 2b, right? Plus 1 over 4, right? Now I'm going to factor negative 1 over e to the 2b out. So it's going to be b over 2, right? Plus 1 over 4, right? Plus 1 over 4 right here, right? Now I'm going to bring this guy back over here. So I have limit when b approaches infinity of, now when b approaches infinity, this guy approaches 0, right? 0 times this guy, it could be 0. The answer is 1 over 4, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.